Hey, grade 9s. All right, let's do it. Last lesson of the unit. That's exciting. Well, I think it's exciting. Okay, so we are going to fill in some blanks here, and then we're going to look at these graphs below. All right, so once we know what a graph means, which we do, and how to understand its equation, which we do, then we can answer some questions like kind of reading graphs and talking about the situation that's shown in them. Okay, so that's what we're going to talk about today in our lesson. So the first way we're going to do that is called interpolating data. So that's that big first word here, okay, interpolating. And that means to read between given points, okay? Oh dear, there we go. Okay, so that means if there are 2 points on the graph, we're going to find information that is between them, okay? And extrapolating data means to extend the pattern. And remember that pattern is another word for slope on the graph to find a point of data that maybe wasn't already given, but we can find. Okay, so again, just to go over the difference here, interpolating means that there are points on the graph and we're going to look between them to find other information. And extrapolating means that the points are not there, so we're going to extend the pattern or the slope in order to find that information that we want. Okay, all right, now before we do any examples, you might notice that in your papers, in your booklets, the graph actually didn't print. That's my bad. I just didn't save the document properly, okay? So I'm just going to zoom in here. I'd like you to pause the video and copy this in, okay? This graph is pretty specific, okay? So make sure you get the right points here. So, for example, like this is a point, and this is a point, and this is a point, okay? So just try to be precise when you do this and use a ruler, okay? So again, just pause the video here and copy this in. I'll wait a second, and then we'll do the questions. Okay, hopefully you have done that now. You've copied it in, and we can take a look at this. So we can see that this graph is showing us a snowmobiling record, okay? So we're looking at somebody snowmobiling over time and how far they traveled, okay? So we're going to first start by determining the equation of the line, which is question A. Okay, so I can't zoom in too much because I need to still see the graph, but zoom in, or pause the video, pardon me, again, if you need to look at your graph a little bit more specifically. Okay, so we know we're going to have y is equal to mx plus b. Okay, so b in this case is really easy, right? Because we can see that here is where the x and y axes meet, and we can see that the graph would be crossing there at 0, 0. So we know that b is going to be equal to 0. I'll just put that on the side. Okay, and then m, again, that's our rise over run. Okay, so we're going to just pick 2 points. I'm going to pick this point, which I kind of already highlighted. You can see it's sort of there. I made a marking earlier. Okay, that one. And this one. Okay, and so when I do that, I'm just going to rise and then run, as always, okay? So we can see that I'm going up here, and now the thing to be careful about, let me try and make that a little bit neater, is that while this does look like we're going up 3 squares, we are, that's true, but remember that we have a different scale on the side now, okay? So in fact, each box doesn't represent 1 anymore, but we can see that if 2 boxes represent 100, then that means every 1 box represents 50, right? So if I went up 3 boxes of 50, that means I rose 150, right? 3 times 50 is 150. And then I'm going to run across here, okay? And again, that doesn't mean 4, even though it looks like 4, because we have to, again, look at the scale down here, okay? So you can see that we started here at 2, and we ended up at 4 hours, right? If you just take a look at the 2 points that we picked. And so because of that, then we know that we ran 2 units, or 2 hours, okay? So m is equal to 75, okay? So that can give us y is equal to 75x plus 0, which, as we know, doesn't change the value of it, right? So we don't need to write that plus 0 in, and so we just have y equals 75x, okay? All right, question B. Why aren't the negative regions of the x and y axes shown? Now, let's think about that, okay? So if I were to extend the y and x axis over here, then I would have negative kilometers down here, right? Now to have negative hours over here. Now, are either of those things possible? I hope that you know that the answer to that is no. Okay, we can't have a negative amount of hours and we can't have a negative amount of kilometers traveled. And so because of that, we only show the positive regions, and that's the answer to B. Okay, so I'm going to zoom in and write that here. And the negative hours especially is the big one, right? Because we can't travel back in time. And so that's the main kicker, although we also can't travel negative distance, right? Every time you move, then it's a positive amount of distance that you've traveled. Oh boy. Okay, there we go. That's the answer to question B. All right, let's move on here. What does the y-intercept represent in this graph? That's what question C is asking us. So I'm just going to change colors for fun here. Okay, so what does the y-intercept represent? Remember that the y-intercept is here, right? We know that at x equals 0 in this case, y also equals 0. And so what that means is that at 0 time, so when the timer started, the snowmobiler hadn't moved anywhere, right? So let me make sure. Yeah, snowmobile. Okay, good. So this means the snowmobiler hadn't gone anywhere yet. So no distance was traveled. Okay. All right, now we're going to look at how far the snowmobiler traveled after 3.5 hours. Okay, so here's our first example of interpolating. Okay, so remember that interpolating means to read between given points. Okay, so we're going to take a look at between 3 hours and 4 hours to find what happens at 3.5 hours. Okay, so I'm going to use actually my highlighter this time. We can maybe see that a little bit more clearly. And I'm just going to make it a pretty small highlighter. There we go. Okay. So let's look here. Between 3 and 4 hours would be along this line, right? So we're going to follow that up until we get to a point here, which is right there. Okay. And so we want to find out what is the y value, what's the distance value at that time of 3.5 hours. Okay, so if I were to just kind of like do a dashed line back here, I know that's not exactly straight. Let me actually just do that with like a better line. Hold on 2 seconds. Okay, there we go. See, so if I use a straight line to go back to the y-axis, we can see that this is above 250. Right, but not quite at 300, okay? So it's in between 250 and 300. And so it's okay to make kind of an approximate guess in this case, all right? That's totally fine. You can also, if you want to make sure your answer is pretty close to correct, you could use your calculator and plug it in to the formula that we created. Okay, so let me just go back down here, and we're going to write our assumption, okay, or our approximation, which I would put maybe at about 260 kilometers, okay? And again, we should check on our calculators to make sure. Wow, that is even worse than the first K. Let's try that one more time. Ah, there we go, that's better, okay? So then you want to just take out your calculator, which is what I'm doing, even though you can't see me, and we're going to take a look here, and we can see that our equation is y equals 75 times x, and so because I've given us our x value here, right, 3.5 hours, I can plug that in. Okay, so we're going to check y is equal to 75 times the amount of hours. Okay, and so when I do 75 times 3.5 in my calculator, we were pretty close. Okay, y is equal to 262, oh dear, 262, there we go, 0.5 kilometers. Okay, so that's the exact answer. Now, if this was on some sort of assessment where we didn't have our calculators, then of course an approximation, like the first thing that we did, would be fine. But because we are in the second half of our year where we can use our calculators, then you can use your calculator. Okay, how far will the snowmobiler have traveled by the 9th hour? Okay, so again, two ways to do this. One is to use our equation, which we'll use to check, and the other way is to first look at the graph and extend it, okay? So I'm just going to pick like a brighter color here. Let's use that green, okay? So you can see that our hours down here, they end at 6. And so to figure out 9 hours, we need to add a few numbers onto that axis, right? And similarly, I need to add a few numbers onto my y-axis because they are not going to go high enough either. So I'm just adding a few here, okay? I'm just arbitrarily doing this. I actually haven't measured it or anything. I'm just going to put a few up, okay? And then I'm going to extend that line, okay? So again, using your ruler, you're going to want to extend that until we are past, ideally, the edge of the graph, but if you don't want to go to the edge of the graph, you can also just make sure you go past 9, which is what we're looking at. Okay, and again, we're just going to follow, wow, that's not a straight line at all, sorry. Oh, goodness. There we go. Okay, so we're just going to follow 9 up to the line to find that point, which is here. Okay, and then we're going to, again, using a straight line, we're just going to go across to figure out the y-axis value. Okay, so use a ruler. You can see my lines are nice and straight. That's what yours should look like too to figure this out. Otherwise, your guess will be a little bit off because you won't be super accurate in your measurement, right? Okay, so just zooming in here at what that y value could be. Again, I can see that it's above 650, but it's below 700. This time, though, it's a little bit more in the middle than it was last time. You can see how this line was like really low down, close to 250. This one is kind of like more in the middle. So I'm going to guess like 675 kilometers, okay? So again, we're going to do an approximation. Okay, and then we're going to check. And this time our x value is 9 because we said after the 9th hour. Okay, and so again, you can plug that into your calculator, which I'm also doing. I know you still can't see it, okay? And that actually is exactly equal to 675 kilometers, so good job us, okay? We were very, very accurate, right? And so the last thing we want to do for both this question and the previous one is we want to end with a sentence because these are word problems, okay? So we can say that the snowmobiler, it's not how you spell, there we go, let's try that again. Snowmobiler has traveled 675 kilometers. Okay, so there's that answer. And then same thing for this question. Just going to go back to that blue to be matching and say the snowmobiler has traveled, pardon me, 262.5 kilometers. Pardon me, ladies. That's weird. I'm feeling totally fine. Okay. Anyways. All right. Next page. Last page, actually, of notes. Okay. Page 18. That's it. We're done after this page. I would like you, again, to just pause the video here and copy this in. Okay. Sorry again about that. I don't really know what happened, but it happened. All right. So pause the video, and then we'll do the questions together. Okay. So hopefully you copied that in. Again, being careful to be precise with your points. Let's do the questions. Okay, so determine the equation of the line shown. So again, we're going to do exactly what we did before in the first example and all the other examples where we found equations of lines. Is we're going to start by taking a look at the b value, that y-intercept. Okay, so that's just right here. Of course, you can do this in the opposite order as well. Like if you want to find the slope first, that's fine. I just like to find the y-intercept first. I'm not really sure why, to be honest with you. It's just like my habit. Okay, so b is equal to 0. And that will go, oh my goodness, no it is not. We're going to find our b value, sorry, is what I'm trying to say. Can't write and talk still, okay. Eraser, there we go. Okay, so b is equal to something where that pink highlighter is. Okay, so we can see that actually the b value there is 50, right? You can see that point is at y equals 50. Okay, so that's going to give us that number there, our B value number. Okay, there we go. And then M, again, we know that's rise over run, right? So we're going to find our slope by doing that. Okay, so M here. So I'm going to pick any 2 points. This time there are actually lots of solid points. Okay, so I'm going to pick this one and this one. Okay, and so we're going to look at the rise. Okay, so again, just wanting you to be careful and to look at the scale there on the axis. Okay, so you can see that we went from 100 to 150. So that's not up 2, right? That's actually up 50. Okay, and then I'm gonna run over to the right. That's very messy, I'm sorry. Whatever, there we go, close enough. Okay, and I'm gonna see that I went from 2 hours to 4 hours. Okay, that's a coincidence that I chose the same ones last time. I just picked 2 random points. Okay, and again, that's moving over 2, so then that gives me an M value of 25. Okay, so that gives me a total answer of y is equal to 25x plus 50. All right, what does the y-intercept tell us? In this case, we can see that the y-intercept here is not 0, right? So that means before the amount of days got recorded, there were already 50 sets of skis rented. Okay, so that means before the graph started, 50 sets of skis were already rented. Okay. There we go. So that's what that tells us. Okay, now how many sets has the rental company rented after 12 days? Okay, so again, you can see that we actually end at 10, right? So we're going to need to extend our line, and we're going to need to do some extrapolating. Okay, so let's take that pen or pencil, whatever you're using. Hopefully it's a pen. That was awful. Okay, there we go. We're just going to extend that line. Again, if you can extend it until it goes right off the graph, that's best. But if not, at least extend it as far as the biggest number we need to find, which is 20 days. Okay, so after day 12 is what we're looking for here. So I'm going to just add some labels here onto the bottom of my graph. So we have knowledge, of all of the values that we need to find. Okay, I know some of those are a little bit messy, but hopefully you can write them in more neatly. And again, I'm also going to just keep extending my y-axis values using the pattern that I can see from the y-axis already. Okay. Whoa. There we go. Okay, there we go. So I filled in all of my x and y axis values, and now we can do some measurement. Okay, so we want to know at 12, right? What is the amount of skis rented after 12 days? So I'm going to pick, sure, why not that green? Okay, and we're just going to do some, oh dear, some highlighting. That's what I'm trying to say. Okay, nope. There we go. Okay, so if I go there, I can see that that is the point. And then again, I'm going to go across to find my y value. So in this case, it was really nice because our x value 12 lines up exactly with the y value of 350, right? So that will make our answer very easy. Okay. Okay, so we're approximating. We're always going to check, right? So check using our equation. Now you might be thinking, well, we don't really need to check this time because we know for sure. You're right. We do know for sure. This was a very exact measurement. But just for good practice, we'll check anyways, okay? So we're saying that y is equal to 25 times x, which is 12, okay, plus 50. Okay, so you can just plug that in to your calculator. 25 times 12 plus 50. That does give me 350 sets. And then we'll finish with a sentence. There we go. Okay, and then how many sets will they have rented by the 20th day? Okay, so this one, we can see actually that our line doesn't go far enough. Hey, I don't know if anybody's picked up on that yet, but if I were to trace 20 all the way up to here, you can see that there's no data at this point, right? And so because of that, we are just going to have to use our equation. Okay, so there's no approximation this time. We're just essentially checking. Okay, so y is equal to 25 times our x value of 12. Sorry, 20, my bad, plus 50. Okay, so then we can do this math, and that gets me to 550 sets. Okay, so then you can say they have rented 550 sets after 20 days. Ooh, that doesn't look like days. There we go. There we go. Voila. Okay, so there we go. That's it. We are done this example. We're actually done the unit. Congratulations, you guys. Feels good, hey? I just want to point out on this page here what can we do with graphs, or what we can do with graphs, pardon me. I just wanted to make kind of like a list here that like summarizes all the information that we've done in this unit. So you can see that these are all things that you know how to do now, and you may need to practice some of them. That's fair. That's totally fine. In fact, you should practice them. And then at some point after spring break, I will be doing some sort of like hand-in assignment instead of a test for you guys, or possibly a small project. I haven't totally decided yet, but these skills on this page are something that you should feel comfortable with. So if you are not feeling comfortable with it, you should be doing some practice. And if you need any extra practice from me, please let me know, and I can upload some more worksheets or activities. Okay, take care of yourselves, you guys. I hope you have a great spring break, and I will talk to you in a little bit.